Welcome to the course of differential equation. In this session, we will discuss about second order differential equations. See, in the last session, we discussed about the linear first order differential equations and many different types of the first order differential equation, and we discussed it is that how can we solve first order differential equation and how we will solve the initial value problem in the case of the first order differential equation. In this session onwards, we will discuss about the solutions of the second order differential equation and different types of the second order differential equation and how we will solve that kind of the second order differential equation. See, in our course, our focus is on the linear second order differential equation. We will discuss on linear second order differential equations. See, my dear students, if suppose this is if we have a differential equation of the form p of x y double dash is y double dash stands for d square y by dx square, okay, plus q of x y dash stands for dy by dx and plus r of x into y is equal to some g of x. See, this is a differential equation. As according to this differential equation, while seeing itself, we understood it is that this is a second order differential equation because the differential equation contains the highest derivative as d square y by dx square. Therefore, this is a second order differential equation. See, and the differential equation of this form is called linear differential equation. Here we have some functions as p of x is there and q of x is there, r of x is there, g of x is there. These are all functions in x, maybe functions in x or a constant, real constants. So, in this case, we can say that this differential equation is linear. This differential equation is linear. And this is a linear differential equation, and see, my dear students, we can change this differential equation. I would like to put this differential equation as differential equation 1, and there is a coefficient of y double dash is there, and y double dash whose coefficient is coefficient function is p of x. I would like to divide this differential equation throughout with p of x. So, what will happen is that divide 1 is divided by p of x. See, dear students, we will have y double dash plus, and while dividing with p of x, the value will be 1, and we have q of x divided by p of x, and the next one is q of x divided by q of x divided by p of x into y dash, plus the next one is r of x divided by q of x. The next one is r of x divided by p of x into y, and finally we will have g of x divided by p of x. See, if p of x is never 0, then this differential equation will be defined and it will works like a linear differential equation. I would like to change this as equation number 2. Suppose I would like to rename this as capital P of x as this one q of x divided by p of x, and capital Q of x as r of x divided by p of x, and finally some r of a capital R of x as some g of x, here g of x divided by p of x. Okay, dear students, we just renamed the coefficient of y dash as p of x and coefficient of y as q of x, and this one right hand side function g of x divided by p of x as capital R of x. So, we will have the equation 2 will becomes as y double dash plus p of x y dash plus q of x y is equal to r of x. So, this is the third equation. So, my dear students, any equation of this form 1 is called a linear second order differential equation. So, such second order linear differential equation can be converted into a linear differential equation of the form y double dash plus p of x y dash plus q of x y is equal to r of x. So, this is the general form of the second order linear non-homogeneous differential equation, second order linear non-homogeneous differential equation. See, my dear students, if r of x is equal to 0, then what will happen it is that if r of x is identically equal to 0, then equation 3 will becomes as y double dash plus p of x y dash plus q of x y is equal to 0. This is the fourth equation. This is the homogeneous second order linear differential equation. So, this is the second order linear homogeneous differential equation. Okay, from this discussions we can divide our second order linear differential equation as two second order homogeneous linear differential equations as well as second order non-homogeneous linear differential equation. In throughout our course, we give first priority for the discussion is second order homogeneous linear differential equation, and also then after that we will discuss about second order linear non-homogeneous differential equations. So, we discussed the linear differential equation. So, in the literature of the differential equation, you can find many differential equation that is not any of these two forms. See that may not be y double dash plus p of x y dash plus q of x y is equal to 0, or that maybe that may not be of the form y double dash plus p of x y dash plus q of x y is equal to r of x. So, there may be another forms are there. See, while discussing, maybe I will give you some examples of the homogeneous linear differential equation. Maybe I would like to give some examples. In this example, y double dash plus y is equal to 0. Say y double dash plus y is equal to 0. So, in this case, the capital P of x is actually this coefficient of y dash, the coefficient of y dash that is not here, therefore p of x is equal to 0, and q of x is equal to, that is the coefficient of y equal to 1, and finally we will have r of x is equal to 0. Since r of x is equal to 0, the equation is homogeneous. So, my dear students, this is second order linear homogeneous differential equations. Say maybe while discussing another example, x y double dash plus x cube y dash plus 3x square y is equal to x raised to 4. See, while thinking about this differential equation, we will have, see, while seeing itself, we will understand is that there is a coefficient function for y double dash. The coefficient function for y double dash is small p of x, and the coefficient function for y dash is small q of x, and the coefficient function for y is small r of x, and finally we will have x raised to 4 is small gx. Okay, fine. Okay, no problem. There is a coefficient functions y double dash plus y x cube y dash is there, plus 3x square y is there, is equal to x raised to 4. So this is this equation keeps the general form of the linear differential equation, so that we can say that this is linear, this is linear. And also we can convert this into y double dash plus capital P of x y dash plus capital Q of x y is equal to capital R of x by dividing the coefficient functions of y double dash. So we will have see while dividing with the x, we will have this one y double dash plus x cube by x, that is x square. So we'll have y double dash plus x square y dash, and again we will divide 3x square with x, therefore we will have 3xy. So we have this is equal to plus 3xy is equal to the r of x is x raised to 4, x raised to 4 by x is x cube. This keeps the general form of linear, and also this is non-homogeneous. Linear and non-homogeneous. See, dear students, maybe we will have one more example. It is that y double dash minus 5 y dash plus 6y is equal to 0. See the differential equation containing y dash, so y double dash and y is there, and the coefficient of y dash is just minus 5, and coefficient of y is a value 6, and the RHS is 0. Therefore this is not homogeneous. So we can say that this is homogeneous linear differential equation. Instead of the functions in x, we have the constants with the constant coefficients. Linear second order differential equation with the constant coefficients. Constant coefficients. Okay, this kind of differential equation we will discuss in our further sessions. Okay, dear students, so we have to think about the nonlinear differential equation. So all the differential equation, none other than the forms that we discussed here, are called nonlinear differential equation. See, my dear students, we can move for the examples of the nonlinear differential equation. And see, we have y double dash into y plus y dash is equal to 0. See, here we have the y double dash is there and also y is there. So they both came in a single term, therefore we can say that this is non-linear. This is non-linear. Say we can move, and one more example it is there, that in example 2, see y double dash plus xy dash whole square is equal to 3x. It's also a differential equation. See, the term y dash is there and y double dash is there, that is a second order differential equation. But see, in the case of first term, okay, y double dash is okay. In second term, there is xy dash square. While expanding this term, we will have this is equal to x square y dash whole square is there. So this y dash square violates the linearity of y dash. Therefore we can say that this is also a non-linear differential second order differential equation. See, my dear students, in our entire discussion, we just keep away the nonlinear differential equation. Our interest is entirely with the linear differential equations and linear homogeneous and linear non-homogeneous differential equations. Okay, anyway, we discussed what is actually the second order linear differential equations. Now, as we did in our first order differential equation, our thought is that how can we solve a differential equation? So, how can we solve, what is the solution of a differential equation? Actually, we know a solution of a differential equation y is equal to a function phi of x is a solution of a differential equation if it satisfies. Okay, this function defined may be any of the interval a less than x less than b, may be infinite. This is a finite interval, maybe interval of length infinity, may can exist, no problem. So, where the function is defined, and we are checking whether phi of t is a solution of the second order linear differential equation. So, definitely this function will be twice defined, that function defined on the interval a less than x less than b, and twice differentiable. The first order derivative and the second order derivative should exist. Twice differentiable, and that makes the equation is identity, and that makes the equation is identity, that satisfies the DE. Simply we can say that satisfies DE. So, we can say that a function y is equal to phi of x, which is defined on a particular interval, that is domain, in a particular domain. That domain may be finite length domain or infinite length domain with infinite length, no problem. So, that is defined and twice differentiable on that particular domain, and if which keeps the differential equation as identity while applying y instead of y and y dash and y double dash in the place of y and y dash, y double dash, we replace with the phi of x, phi dash of x and phi double dash of x. So, if that satisfies that differential equation, we can say that that is the solution of the differential equation. We can just move with the simple problems. See, my dear students, in example 1 we will have, maybe we discussed it, is that we have a simple differential equation y double dash plus y is equal to 0. I would like to put this as a differential equation. Okay. Say, suppose y is equal to cos x. Suppose y is equal to cos x. Okay. Y is equal to cos x. Say y is equal to cos x is continuously differentiable function in throughout the domain, entire real in the entire real line, it is defined and differentiable. So, we can have here we have y is there, y dash, y double dash is there. So, we just finding y dash, derivative of cos x, that is minus sin x, is there, and the next one is y double dash is there, y double dash is equal to minus derivative of sin x is cos x. Okay, put in equation 1. See, dear students, what will happen, it is that instead of y dash we will apply minus cos x, instead of y we will apply plus cos x. So, minus cos x and plus cos x, the value is equal to 0. Okay. So, we can say that while applying y instead of y as cos x, while applying cos x instead of y, we can say that the equation 1 satisfies. So that we can say that y is equal to cos x is a solution of differential equation 1. Think about sin x. Think about sin x. So what will happen in case of y is equal to sin x? Y is equal to sin x. So the differential equation is same, y double dash plus y is equal to 0. Okay, y dash is there, y dash is equal to derivative of sin x, that is equal to cos x, and y double dash is there, y double dash, while evaluating y double dash, derivative of cos x, derivative of cos x is minus sin x, derivative of cos x is minus sin x. So put in this differential equation 1, put in 1, we will have y double dash, instead of y double dash we will have minus sin x, instead of y we will have plus sin x. Okay. Okay, the value will be equal to 0. So while applying y is equal to sin x instead of y in equation 1, we will have the equation keeps the identity, that means satisfies the equation. So that we can say that y is equal to y is equal to sin x is a solution of differential equation 1. Think about their sum. The y is equal to sin x is a solution and y is equal to cos x is a solution. So think about their sum. Check whether is y is equal to sin x plus cos x is a solution of y double dash plus y is equal to 0. The differential equation is same, that is linear and homogeneous. See my dear students, we have to check whether y is equal to sin x plus cos x. Say y dash, to check whether that is solution or not, we will find y dash. Y dash is equal to derivative of sin x is minus cos x and derivative of cos x is derivative of sin x is cos x, derivative of cos x is sin x, derivative of sin x is cos x, derivative of cos x is minus sin x. Okay, fine. Okay, y double dash, while evaluating y double dash, this is equal to derivative of cos x. Derivative of cos x is minus sin x and derivative of sin x is cos x. Already we have minus sin with the sin x is there. Okay, put in 1. What will happen is that the y double dash is minus sin x minus cos x is there, plus y is actually plus sin x plus cos x is there, plus sin x plus sin x plus cos x is there. See dear students, we will have the plus cos x and minus cos x we can cancel, plus sin x and minus sin x we can cancel. Finally we will have the value is equal to 0. So that satisfies the equation. See, sin x is a solution of this differential equation and cos x is also the solution of this differential equation, and sin x plus cos x is also solution of this differential equation. Think about their constant multiple. See, while we will move to next example. Example 3, y is equal to c1 sin x plus c2 cos x. For convenience, I just combined both the constant multiple of sin x and cos x. Say we have this differential equation is y double dash plus y dash is equal to 0. Okay, y double dash plus y dash is equal to 0. So, we will have y double dash plus y is equal to 0. Y double dash plus y is equal to y dash is equal to C1 is a constant derivative of sin x. Derivative of sin x is cos x. C1 cos x plus C2 is a constant derivative of cos x is minus sin x. So, minus C2 sin x. We can evaluate the second order derivative y double dash is actually C1 cos x, derivative of cos x is minus sin x, therefore, the value will be minus C1 sin x plus derivative of sin x is cos x, already we have minus sign with this term, therefore, we will have minus C2 cos x. Okay. Put in 1. So, we will have y double dash is equal to minus C1 sin x minus C2 cos x plus C1 sin x plus C2 cos x is there. Finally, we will have the values plus C2 we will have the value plus C2 cos x minus C2 cos x is there, and also we will have the value plus C1 sin x plus minus C1 sin x is there. So, we will have the entire value will be equal to 0, satisfies the equation 1. So, what we understood from here it is that, see, in our example 1 we used y is equal to sin x is a solution and y is equal to cos x is a solution of the same differential equation, and their sum is a solution of the same differential equation. And see, finally, what we discussed it is their constant multiple is also a solution. Sum of the linear combinations of the two solutions is again the solution of the differential equation. So, our discussion is that it is valid in all cases, that is it valid in all differential equations in homogeneous and non-homogeneous there. So, that we will discuss in our further sessions. And see, my dear students, I will just changing a little change on our differential equations. Verify in our next example in our example 4, verify e raised to x is a solution of the differential equation y double dash minus y is equal to 0. See, I just replaced only, here we have the equation 1 is y double dash plus y is equal to 0. Instead of that, just I changed for the convenience, I would like to call it as equation number 2. See, y double dash minus y is equal to 0. See, we have verify e raised to x is a solution. Instead of phi of x, here we have e raised to x is there. So, we have as part of the solution, we just put y is equal to e raised to x, y dash is equal to again e raised to x, y double dash is again e raised to x, derivative and integral of e raised to x is again e raised to x. So, definitely we will have the value as y double dash is equal to e raised to x, that is e raised to x minus y is e raised to x minus e raised to x is equal to 0. So, okay, the keeps the identity as 0. See, that will keeps the identity as 0. Fine, okay. Now, see, what about e raised to minus x? E raised to minus x, see, in the next example, we use y is equal to e raised to minus x. The differential equation is y double dash minus y is equal to 0. Okay. So, we will have this is equal to y is equal to e raised to minus x and y double dash minus y is equal to 0, y dash is equal to derivative of e raised to minus x. that is minus e raised to minus 6, and again y double dash is equal to derivative of minus e raised to minus 6, that is plus e raised to minus 6. Okay, fine. This is our equation 2 is here, put into. So, we will have y dash is there and y double dash is there. So, the y double dash is e raised to minus 6 and y is equal to e raised to minus 6. The value will be equal to 0. So, keeps the equation. As we did in previous example, have to check whether is C1 e raised to x plus C2 C1 e raised to x plus C2 e raised to minus x is a solution of y double dash minus y is equal to 0. That is our equation number 2. Okay, while evaluating this as we consider this as y, C1 e raised to x plus C2 e raised to minus x. Okay, we can find y dash. The y dash is equal to C1 e raised to x, derivative of e raised to x is e raised to x, C1 is a constant, so derivative of e raised to minus x is minus C2 e raised to minus x. Okay, while evaluating y double dash, derivative of C1 e raised to x is there, C1 e raised to x is there, derivative of C2 e raised to minus x, derivative of e raised to minus x is minus e raised to minus x, and there exists two negative signs, therefore plus C2 e raised to minus x is there. See, while putting this values on equation number 2, on the differential equation 2, my dear students, put in 2. So, we will have the value, put in 2, we will have the value y double dash, that is equal to C1 e raised to x plus C2 e raised to minus x minus y is there, that is again C1 e raised to x plus C2 e raised to minus x. Okay, C1 e raised to x minus C1 e raised to x is there, C2 e raised to minus x minus C2 e raised to minus x is there. Finally, we will have the value will be 0, satisfies the equation. So, what we found it is that if e raised to x is a solution and e raised to minus x is a solution, then their linear combinations C1 plus C2 e raised to x for two arbitrary constants C1 and C2 is again a solution of the equation number 2. So, this two problems will give rise as to some questions. If y1 is a solution of a differential equation and y2 is another solution of a differential equation, there are two different solutions are there for a differential equation, is C1y1 plus C2y2 is a solution of differential equation. So, that arises a question to us, that is the answer is will give by the fundamental theorem of differential equation, that we will discuss in the next sessions. Okay, so we can move to some examples. Say write down some assignment questions. Verify e raised to 2x, e raised to 3x are solutions of differential equation y double dash minus 5y dash plus 6 equal to 0. Okay. So, similarly, write down the next question. Verify e raised to minus 2x plus e raised to minus 2x or e raised to minus 3x are solutions of differential equation y double dash plus 5y plus 6 is equal to 0. Okay, the question have some little similarities there, but while evaluating that one, you will get a very nice idea from there. Okay, try to solve this problem. Thank you for watching these videos. Continue watching. Thank you very much.